Hello and welcome to this tutorial on SQL Joins. In this session, we will learn how to use SQL Joins to combine data from multiple tables in a relational database. Before diving into SQL Joins, it is essential to understand some foundational concepts in SQL and relational databases. If you're a complete beginner to SQL, you may consider watching my previous SQL tutorial. I will update the link for that video in the description box. Once you're comfortable with the basics of SQL, you are ready to dive into SQL Joins. By the end of this tutorial, you will understand the most commonly used joins like inner join, left join, right join, full outer join, and cross joins. Alright, let's dive into the fascinating world of SQL joins. So, what are SQL joins? SQL joins allow you to combine data from two or more tables based on a related column. They are essential when working with relational databases, where data is stored in multiple tables to reduce redundancy. Joins let you connect these tables and analyze related information. Now we learned what are joins. Then, what are the benefits of joins? Joins allow efficient data retrieval. Joins allow you to retrieve related data from multiple tables in a single query, eliminating the need to write multiple queries and compare results manually. SQL joins support data consistency. Data consistency refers to ensuring the integrity and accuracy of data when combining multiple tables in a relational database. SQL joins ensure that your data remains consistent, reliable, and meaningful. Join helps you to reduce data duplication. Joins enable data to be normalized and stored across multiple related tables, minimizing data duplication. For example, instead of storing customer details in every order records, you can store customer details in one table and link it to the orders using a join. In summary, SQL joins are essential for efficient data management, reducing redundancy, and enabling powerful and flexible data queries in relational databases. There are multiple types of SQL joins available. They are inner join, left outer join, right outer join, full join, and cross joins. We will discuss each of them in detail. Before that, we should get familiarized with the tables that we are using today. We have two tables, customers and orders. The customers table stores customer ID, first name and last name of customers. Orders table stores the data such as order ID, customer ID and order status. Let's start with inner join. Inner join returns only the rows where there is a match in both tables. For example, if we have a customers table and orders table, we can find all customers who have placed orders. Look at the diagram. The intersection that is highlighted with blue represents the matching rows that exist in both tables based on the join condition. The inner join syntax combines rows from two or more tables based on a matching condition. The keyword select specifies the column to retrieve from tables. The keyword from is followed by our first table and is followed by the keyword inner join, which specifies the second table to join with the first table. And finally, the on keyword specifies the join condition that determines how the rows from two tables are matched. Now we can try an example. In this query, I am retrieving customer ID, first name and last name from the customers table and order status from the orders table. You can see the result. The customer ID, first name and last name from the customers table and the corresponding order status from the orders table is retrieved. Now we can move on to left join. The left join Or left outer join returns all rows from the left table and the matching rows from the right table. If there is no match, it returns null for the right table's column. Just have a look at the diagram. Here, all the records in table 1 is highlighted with blue and the matching records in table 2 is also highlighted with blue. This is going to be the result of our left join query. The syntax for left join is similar to the syntax of inner join, but it uses the keyword left join instead of inner join. You may either use the keyword left join or left outer join. This is our previous query. Here, I am replacing the keyword inner join with left outer join. You can use simply left join. See the result. All the records from the customers table is retrieved and also the matching records from the orders table. You can see that we don't have a matching record for customer ID 5 in the orders table. So it returned a null. This is how the left join works. Now let's move on to right join. The right join works the opposite way of left join. It returns all records from the right table and the matching records from the left table. You can understand it from the diagram. The syntax is also similar to left join, except the keyword right join. From our previous query, I am just replacing the keyword left outer join with right outer join. You can see we have customer ID 1, 2, 3, 4 and 6 in orders table. We don't have the customer ID 5 available in the orders table. So it returned all records from the orders table and null for the records that are not available in the customers table. We learned left outer join and right outer join. Actually, full outer join is a combination of left and right outer join. A full outer join combines the results of both left join and right join. It includes all records from both tables, with nulls where there is no match. The syntax is also similar to left join and right join. Now, let's see how a full outer join works. Unfortunately, MySQL does not support full outer join. But some other databases like Oracle and PostgreSQL support full outer join. But in MySQL, we can achieve the same result with a combination of left and right outer join. We are using union operator for that. The union operator in SQL is used to combine the results of two or more select statements into a single result set. Here, you can see that the data from both tables is fetched, with null where there is no match. Now we can learn what a cross join is. A cross join returns the Cartesian product of the two tables. It matches each row from the first table with every row in the second table. The diagram on the right side shows how data in both tables is combined. The syntax for cross join is different from other kind of joins. It starts with the keyword select followed by the column names, then followed by from where we mention our first table, and finally the keyword cross join followed by second table's name. Maybe an example will make it much more clear. Follow the same syntax that we discussed earlier. We are doing the cross join on customers and orders table. Once you are done, just run the query. Just see, it returned 35 rows. Now you may wonder why this is used. At first glance, it seems inefficient. But cross joins have specific use cases in data analysis. Cross joins are used when you need all possible combinations of two datasets. But we should avoid using cross joins in some situations. The Cartesian product generated by a cross join grows exponentially with the size of the table. This can lead to memory issues, slow performance, and unnecessary resource consumption. When you're combining two large datasets without any filtering, it can produce an enormous result set. So, it's better to avoid cross joins with larger datasets. Or else, we can limit the dataset size before performing a cross join by using clauses such as where, limit, etc. Here you can see that the number of rows returned is reduced to 20 once I applied a conditional statement. I hope you understood what a cross join is. Now it's time to conclude our video. Today we learned what is a join and what are different types of joins. You may practice the queries that we discussed with your own datasets. Thank you for joining this tutorial. At any point, if you found this tutorial helpful, please consider subscribing to this channel. Thank you once again.